everybody and welcome to this video. In this video, we're just going to practice some of the probability that we've been doing over the past few videos. So let us have a look at this exercise. So it says a passcode has 4 digits. Digits can be repeated and you can use digits from 0 to 9. And it says, what is the total possible number of passcodes? So we have 4 digits and we're going to put the number of options for each one. So for the first digit from 0 to 9 is 10. And then the second one, we allowed repetition. So we have 10 again. For the third one, we have 10 again and 10 again. So that's 10 to the power of 4. That's the total number of digits that can be done with a 4-digit code. Then it says, what is the probability of correctly guessing the first digit? So again, we're starting with the 4 digits. So for the first digit, there's only one that's correct. So the probability that we get that one that is correct is 1. We can then guess any other one for the next 3 digits because we only want to get the first one correct. So the probability of you getting the first digit correct is 10 to the power of 3. So then it says, what is the probability of guessing the first and the second digit correctly? So again, using the counting fundamental principle, there's one digit that's going to be correct for the first one. So there's only one way of choosing the first digit. Again, there's one digit that's correct for the second one. So there's only one way of choosing it. Then for the third and fourth digit, it does not matter as long as we have the first 2 digits correctly. So we have 10 options for that. So it's 10 to the power of 2. Let us have a look at the next exercise. So it says there are 4 green balls and 3 yellow balls in a bag. 2 balls are drawn without replacement. So we're not replacing them. And it says draw a tree diagram to represent the outcomes. Okay, so on the tree diagram, we're first going to have us drawing the first ball. And we have 2 options for the first draw. We can either get a green ball or we can get a yellow ball. We have to add the probability for that. So the probability for a green ball, there are 4 over the total, which is 7. And the probability of you getting a yellow ball is 3 over 7. So that's the first ball. Now we're going to draw the second ball without replacement. So we have that the second ball can either again be green or yellow. So let's look at the first branch. We've already chosen a green ball. So there's one less ball and that ball is green. So the probability of us getting another green ball, well, there's one less green ball, so it's 3, and there's one less ball in general, so it's 6. There's still the same amount of yellow balls, but we have one less ball. So the probability of us taking a green ball after we've got a green ball is 3 over 6, because there's one less green ball. Let's look at the bottom. The probability of us getting a yellow ball first and then getting a green ball. So we've already got a yellow ball, so there's one yellow ball less. So there are still 4 green balls, but now there are 6 balls because there's one ball less. And then yellow and yellow, there's going to be 2 yellow balls left out of the 6 options that's left if we choose a yellow ball. So our outcomes are green, 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 yellow, yellow, green, and yellow, yellow. And to get the associated probabilities with each one, we multiply the branches to get to that particular combination. So it says, okay, so let's actually first calculate those probabilities. So let's say we wanted the probability of green, green. That's going to be equal to 4 over 7 times 3 over 6. So 4 over 7 times, 3 over 6. So it's 12 over 42. The probability of green, yellow, that particular one is 4 over 7 times 3 over 6. So again, it's 12 over 42. The probability of yellow and then green is 3/7 times 4/6, which is 12/42. And finally, the probability of yellow is 3/7 times 2/6, which is 6/42. So those are the probabilities associated with all our events. So it says, what is the probability that you draw two balls of the same color? So which ones are we considering here? We're considering the combination of green, green and yellow, yellow, because those are two balls of the same color. So two balls of the same color that is equal to the probability of yellow, yellow plus the probability of green, green. And we've already calculated those probabilities in the numerator up above. So it's 6/42 plus 12/42, which is then 18/42. If you wanted to simplify that, you could, and you would get 3/7. So that's the probability of you drawing two balls of the same color. I hope that you have understood these examples. In the first question of the exercise, we looked at the fundamental counting principle applied to different cases. And I hope that you understood what happens when we have certain requirements, then it changes the number of options on those restrictions. And the second one was a tree diagram with two events without replacements, representing it on a tree diagram, calculating the probabilities, and finally finding out particular probabilities. I hope that you have understood this video. Please like and subscribe and watch our other videos on probability. Thank you for watching. Bye.